All right, welcome to day one of our Python course, phase one, day one. My name is Sahas Poekar. I'll be your instructor today, kind of guiding us through the kind of introductions of Python programming. And joining me today is Scott Vo, Stephen Dong, and Ellie Cheng. Would you guys like to introduce yourselves?
Yeah, sure. Thanks, Hoss. So I'm Scott Vo. I'm a third year computer science major. And today I'm going to be manning the computer and doing all the typing while Sahas can focus on doing the instruction. And I'll pass the mic to Stephen really quickly.
Hello, everyone. My name is Stephen Dong. I'm also a third year computer science major. I'm not actually instructing any of these sessions, but I am going to be the one responsible for a lot of like the reference materials that you might be getting after some of these sessions.
Right.
All right. And Ellie, are you there?
Yep, I'm here. So my name is Ellie, also a third year CS major, and today I'll just be moderator.
All right, cool. Why don't we go ahead and get started then? Before we do get started though, does anyone have any questions or anything from last session that might not be working that we can kind of very briefly take a look at before we get started? All right, if not, then I think we can go ahead and get started with today's lesson. So I want everyone to first go ahead and open up their VS Code, and if you guys want to follow along. Last class we did set up a folder with a Python file inside of it. For those of you who kind of missed that or didn't catch up to that, the way that we can create a new folder and add that into VS Code, it's pretty simple. You can go into File, and then go to open folder, and then you can find any folders that you want to be putting all of your Python files inside of. And once you go ahead and select that from your file explorer, you just go ahead and hit select folder and it'll add all that stuff into our explorer. And then from there, you can quickly and very easily add new files by clicking new file. And VS Code is really great because it can automatically detect what programming language that you want to use when you are creating a new file. But yeah, so let's move on and start learning some of the basics of Python. So let's go to our day1.py and let's go ahead and begin. So the first thing that we kind of want to discuss when working with Python are variables. Variables are really important tools that we use whenever we want to store any kind of specific information. Now, for those of you who have done C++, you might have already kind of seen variables, but variables work a little bit differently in Python than it does in C++. So one example for how they're different are in C++, you need to usually define what data type you want to store for a variable. So if you want to create a variable that stores numbers, you would say int and then the variable name. But in Python, it's actually more clever and it uses something called dynamic casting, which it'll be able to detect what kind of data you want to store into your variable. And for those of you who don't know what variables are basically kind of like containers or boxes that you use to store any kind of information in, so you can take a look at that later and or change it, manipulate it in any other way. So why don't we go ahead and start by creating a variable in Python. The way we do that is we want to follow kind of a semi-strict naming scheme similar to the ones in C++, where you want to, whenever you create a variable name, you want to make sure that it starts with a letter or an underscore. It doesn't have any special symbols like exclamation mark or ampersand. And you also can have numbers inside of the variable name, but it cannot begin at the very, you can't start with a number with the variable name. So for example, you can use a variable called day1 or day underscore one, but you can't do one underscore day. That won't work. So for now, yeah, so day one works. So for now, let's go ahead and just create a variable called a. So it doesn't particularly have to store any kind of information. Um, we can use it for anything, and we'll first go ahead and store what our first of four different data types that we want to talk about, which is integers, ints. Integers are basically just any whole numbers, negative or positive. So you can go like -5, 0, or 10 are all whole numbers, are all integers. And what Scott just went ahead and did after the number 10 is he put a comment in Python. So comments are usually written with a hash, and anything following that hash will be kind of commented code, basically code that won't run when you hit the play button or try to run a Python program through terminal. So you can see there that a equals 10, it's stuck in the comment because of that hash. But yeah, so that's just so for those of you who were wondering how you can do comments in Python, you just use hashes instead of maybe double slashes that you might have seen in C++. But anyways, we have a variable called a, and it's storing the integer 10. Why don't we go ahead and try printing out that integer using the print function that we kind of took a look at last class. So whenever you want to print out a variable, it's as easy as writing the function name, which is print, and inside of the parentheses, you want to pass in or provide some kind of item for our print function to kind of take in and run with. In this case, we just pass in the variable a. Now notice how Scott put the letter a just by itself in the parentheses. So when we go ahead and run this program, we'll expect it to print out the number 10 because it'll take what's being stored in variable a and print that out. So let's go ahead and try running that program. There's two different ways we can run our program. The first way is by running it through our terminal. So you can, in order to do that, you just write you write Python and then the name of our file that we would like to run. You do want to make sure, however, that you are in the correct directory or the right file location to run that program. If you were, say, in like a completely different drive or a different folder where that file isn't located, so Scott's going to kind of take us out right now, and we did Python and the name of our file, it won't run because it's not able to find that file. So you want to make sure you're in the right directory. And what Scott went ahead and used cd change directory. Um, that's what you want to use when you want to change and go in or out of files. So this is kind of like basic Linux commands. You don't necessarily need to know all of these. Just make sure that when you open your terminal, it should automatically have you in the right spot. So we're going to do Python and then the name of the file. Let's go ahead and hit run or hit enter, sorry, and it prints out the number 10 because on line 3 we want to print out whatever variable a is storing, which is 10. Now, if we put a instead of quotation marks, which makes it our second data type a string, then instead of printing out what a variable a is storing, it'll instead just print out the letter a. So let's go ahead and run the program again, and let's show you the second way we can run this program. If you have VS Code all properly configured, you'll see that there's a run Python file button on the top right of your screen. If you go ahead and click that button, it'll automatically open up a terminal if it isn't open already and execute the code. So let's go ahead and click that. And there we go. Just the letter A gets printed out in this case. So that was our second data type. Now let's go ahead and reverse that. So we have our variable A being a variable instead of a string. And we can show you how we can take one data type. We can take one variable that's storing one data type and immediately switch it to a different data type. So on line 2, if we did A equals hello world, now in C++, for those of you who came from a C++ background, you'll know that this is not possible because data type, or when a variable is first created, it can only store whatever data type it's kind of been assigned to store. So in this case, A would have only been able to store 10 if we were in C++ or some other programming language. But in Python, we can actually dynamically cast and change what a variable stores as our program is running. So one time our variable a can be storing the number 10, and on the second line, our variable can be storing a string hello world. So when we go ahead and run this program, we should see that it prints out hello world instead. So let's go ahead and run that.
Sorry about
Yeah,
that.
we got
Forgot
hello
to
world.
save the file. Remember to save the file, y'all.
Oh yeah, make sure
It'll save you.
when programming, it's always important to save the file. Oh, and one other thing that people who came from a C++ background might have noticed is we aren't actually putting semicolons at the end of any of these lines of code. Semicolons are not necessary at all for Python. It's a more script-based language, so it runs things line by line, and it uses a different technique to kind of figure out when a particular line of code is kind of complete in its own thing. But yeah. All right. So those were the first two data types that we talked about. Are there any questions? Aaron brought up an interesting question. Uh, we don't need an int main or anything like that. Yeah. So actually, with Python, since it's more akin to a scripting language, it's going to run lines sequentially from top to bottom. Whatever it sees, it'll try to run. We do use a different method of kind of storing stuff as main. Scott, why don't you go ahead and write out how we do mains in Python for us? So we go ahead and do if underscore underscore name underscore underscore is equal to underscore underscore main underscore underscore, and the colon at the end of an if statement means we want to put some stuff inside of this if statement. So yeah, as Scott is saying, that this will run as if the script this runs if the script that you're currently running is kind of the main file. So we basically use this as our technique of running main files. We don't particularly have a main function that we want to be using in Python. But yeah, that's because of how Python works. It's more script based instead of compiling everything and running it from there. Yeah. All right, so the other two data types that I wanted to talk about were floats and Booleans. So we'll quickly go ahead and show those. So a float is basically decimal numbers. So it's basically an integer, but now you have decimals included as well. So 3.14 is a float. And then Booleans, those are pretty easy. The Boolean can only be two different things. They can either be true or false. Now with Python, whenever we want to do true or false, we had to do it with the capital T or capital F for true or false respectively. But yeah, so those are our data types. Now we can kind of move on to some other stuff that I wanted to mention with our print function. So our print function so far, we kind of left it very bare bones. All it does is takes in a variable and prints out whatever it's storing. Now there's a few other things we can do with our print function that's also useful. If we have multiple items that we want to print at the same time, so let's say we had a variable A that stored one item and a variable B that stored something else, and we want to print them both on the same line. So let's go ahead and turn one of these variables into a variable B. Yeah, so we have a variable A that stores the string hello and a variable B that stores the string world. If we want to print them both at the same time, we can say A comma B. So our print function can take any number of strings that are separated by commas. And this doesn't have to be just strings. It can be actually any kind of variables, integers, floats. It'll store and print all of them at once. But you do have to make sure that you have a comma separating each one of them. So let's go ahead and run this and see if hello world gets printed out. And there you go. So another kind of thing you want to remember when using the comma is our print function will automatically separate each item in our print function with a space. Now, there are other ways we can kind of manipulate how our print function works. Now, if we had two print functions right next to each other, so we print A, B, and then maybe on the next line we want to print, I don't know, Scott, or hi there, yeah. And then we go ahead and hit run. We'll see that print AB will run on one line, and then we go to a new line to print hi there. So every time you do a print, it'll automatically go to a new line for our next print. Now, if you want to overwrite that or change that, we can use a special kind of parameter for our print called end. And so after B, we can put a comma and then effectively change our keyword end, our parameter end. And by default, end will want to put a new line. But we can actually change that to put space instead, for example. So let's go ahead and put a space inside of the end. So we have a string that kind of acts as a space. Then when we hit run, we'll have hello world and then hi there all showing up on the same line. Siddharth has a question. In Python, does versus, oh, so double quotations versus single quotations, they, I believe, don't have any differences. They both effectively work the same way.
Yeah, so if I could interject really quickly. Yeah, so basically the only reason you would need to think about whether you want to use single or double quotes is that let's say if you had a really long string that had, like an apostrophe in it. So if I had, for example, Scott's coffee. See how it kind of broke. So that's something that like you could use special characters, or Python's pretty smart and it sees that, well, we have double quotes surrounding the string. So a single quote doesn't really matter that much to it. It's just like a regular single quote.
Yeah. All right. So as you can see, kind of moving on from there, our end keyword will now let us put a space between a print instead of a new line. Now the other kind of parameter that we'd like to take a look at is the sep parameter. Sep, short for separating, will let us figure out how we want to separate our strings. So by default, it'll do it with a space, but we can instead separate maybe with a dash. So we can put a string that just contains a dash, and then now it'll separate each string with a dash instead. So we'll say hello dash world instead of hello space world. And there are a bunch of other things you can do with print. So when you create a print function and hover over it, you might see a bunch of other parameters that are kind of involved with it. So you can kind of take a look at the documentation and see how all of those work on your own time. There is another way you can do string concatenation. So the process of taking two strings and kind of combining them is called string concatenation. And that's done most of the time with a plus, but as we saw earlier, we can also use a comma with the print statement. So if we want to combine the word hello and world, we can do print A plus B. So we'll take the contents of variable A and add that with the contents of variable B and put them together. Or yeah, you can also effectively do the same thing by hard coding those strings in. So now we get hello world, but unlike with commas, it'll just take those two strings and put them together and you would have to manually put a space in. So yeah, you can do that this way as well, where we do A plus space plus B, and it'll effectively put a space between hello and world. So you can kind of string together and combine or concatenate multiple strings together. All right, now moving on from print functions, there is another kind of function that's really integral to Python if you want to do input output with users, which is the, well, opposite output would be input. So we will be looking at the input function next. So our input function effectively works similar in a way with print functions where it will print a prompt out to the user, but this time the user will be able to type something back in our terminal and we can store that into a variable. So typically the way you want to write inputs are you would want to first create a variable that'll store what our input will kind of capture from the terminal. So let's create a variable called user input on line 18. And we want to set user input to whatever our input kind of captures from terminal. So to use the input function, you just write the name of the function input followed by parentheses. Now inside those parentheses, we can include a prompt or something that'll allow the user of our program to kind of figure out what they should be typing. So we can say, please enter your name. And that when what Scott went ahead and did was he put a colon and a space after name. If he didn't include that, whenever you type something into the terminal to kind of give your response to the input statement, it'll kind of attach that after name. So it'll kind of look like you're extending more letters after a name and making kind of a mess of a word. So you do want to add like a little separator after whatever prompt you want to give to a user. So we have please enter your name colon space, and our user will be able to type something that gets stored into user input. And let's kind of echo that back to our user. Does anyone know how we can kind of display whatever the user typed into the terminal back onto the terminal, kind of like an echo? What can we do here? Right, we can do print user underscore input. So we get our input from our user, store that into user input, and then we can immediately print that back. So when we type in a name, it'll print that immediately back after. Cool. So a few things that we want to kind of talk about with inputs. They work similar with prints in the terms of how you can print out stuff as prompts, but unlike print functions, which uses commas to separate multiple variables, you can't use that same trick with inputs. So if you want to combine different strings together, you'll have to use string concatenation using pluses. And another thing you want to note with input is whenever you input something, it'll immediately store that information as a string instead of, let's say if you typed in a number, it won't store that number as an integer, it'll turn that into a string instead. So you'll have to use tools like typecasting. And typecasting is the process of converting one data type into another. So you'd use that to turn a string into an integer if the user wants to type in a number instead. So here Scott is taking in age, which will be stored as a string into user input, and using int, which is the integer typecasting function, to turn that string into an integer. So now if you wanted to add 1 to the age, so you can do +1 at the end of that, and it'll do a mathematical equation of 20 plus 1 instead of a string 20 plus 1, which wouldn't work. And there we go. All right. Well, so that's everything in terms of input, output with print and input functions. Any questions before we move on to the next topic? All right. So the next topic we want to go over are conditional statements. So conditional statements are your if, elif, and else kind of put into something called a conditional block. And we use those a lot in programming whenever we want to control the flow of our code. So so far everything we've done. Oh, I have a quick question. So is user input only an int with the print function within the print function? Yeah. So right now when Scott did print int user input, it dynamically, or it does a typecast from string to integers just for that print function. If you do want to effectively change user input to be an integer, you would say user input equals int user input, and that'll take our string and turn that into an integer and store that back into user input. Good question. All right. So anyways, with conditional statements, we use conditional statements a lot when we want to control the flow of our code. So far, everything we've done has been kind of sequential. So we run line 1, line 2, line 3, all the way until there's no more lines of code to run. With conditional statements, we can kind of control which set of code should run when a particular kind of, when something is true or false. So we have more control of what runs and what shouldn't run. And that kind of gives us more control and allows us to create more kind of algorithms based off of different inputs. Now, with conditional blocks and conditional statements, the most important one that you always want to start off with is our if statement. So if statements work similarly to how you've seen in C++, where we want to first use the keyword if. Now, unlike C++, where we need to put parentheses after an if statement, that's not necessary here. We can immediately go into something called a Boolean expression or equation to check whether one thing is true, false, and if something is true, so if our statement is true, then we run our code inside our if statement. So how do we do that? Well, right now we have a variable called x that stores the number 5. Now let's check if x is equivalent to 5. So if we want to check if two things are equal to each other in Python, we do the double equal sign. This is different from a single equal sign, which we use for assigning. So right now we have if x is equivalent to 5. Now, if that statement is true, then we can run maybe a print statement that says x is storing 5. The way we do that is at the end of our if statement, we want to put a colon. The colon lets Python know that we are now writing code for our if statement. So when you do colon and hit enter, it'll immediately tab you in. Those tabs are basically letting you know and Python know that we are now writing code that'll only run if our if statement is true. So what we're doing is checking if x is equivalent to 5. If that is true, which in this case it is because x is storing the number 5, then we want to print out x is equal to 5 or something like that. Let's go ahead and do that. So we have x is equal to 5. When we run this, our print statement will run. And then if we change it to x is equal to 6 and run that, absolutely nothing happens because right now 6 is not equivalent to 5, making this if statement false. So if false, we just skip that whatever's inside our if statement and carry on. We have a question in the chat. what if it's tabbed, but there's an extra line between if and print? Oh, in that case, it'll work just the same. So any lines that have been tabbed inside of our if statement will be treated as part of that if statement. Yeah, and we can have another print statement with a bunch of spaces or new lines between them, and it'll work the same way. So we have x equals 5, and then sneaky print. All right. Now, to continue on our conditional block stuff, another conditional statement that we can use is the else. So on the next line, let's go ahead and include an else statement. And to make sure you're no longer in our if statement, you're going to make sure you backspace out so you no longer want to be tabbed inside. If you did write our else inside of the if statement or have it tabbed in, it wouldn't work because an else requires some kind of an if statement to kind of be attached to, and that's part of our conditional block statements. So in this case, we have a conditional. Oh, quick question. Wait, how do you print specific lines again? Um, could you maybe elaborate? What do you mean by print specific lines? Like lines of code. Well, with prints, you want to use the print function whenever you want to print something onto the terminal. So we just use print followed by parentheses because all functions require parentheses at the end of it. And then you can include some variable text or anything inside of the print function and it'll try to print that out. So on line 26, we have a print function that prints out a string that says x is 5. Does that answer your question?
Yeah, and if I'm understanding your question correctly, you actually can't print stuff from code inside of the Python file. So, for example, you can't print out line 22. This is kind of us knowing, like as a human, we know that we set x equals 5 and our condition is if x is 5. So we kind of just print that. But in terms of the actual code that we're writing, we can't directly print it.
Well, moving on with our conditional statements. Oh no, I was asking how the output only shows a few lines instead of the whole code.
Oh, do you mean like these lines over here? Okay. So yeah, once again, these hashes are basically our comments. So if there's a hash at the beginning of this line, then the rest of that line is basically useless in terms of code, and it's only for they're just comments. So if I had really complex code that I forgot how it worked, I would say like I would give a description of it. So like that the Python doesn't really look at that at all, but we can look at it. Yep, exactly.
Yeah, and a quick way that you can convert a code from comment to uncomment is if you highlight whatever code you want to turn into a comment or uncomment, and then you do, is it shift slash, Scott? Or alt?
So if you're on Windows, it's going to be control forward slash. So the one that has the question mark on it. And if you're on Mac, it'll, I believe, be command forward slash.
Yeah, I believe that's correct. So that's how you can quickly switch a piece of or line of code from commented to uncomment.
Yeah, and that usually works in every programming language.
All right. Now moving on with our else statement. So our else statement follows a similar rule set as our if statement, where we want to put a colon at the end of it, and when you hit enter, we'll kind of be tabbed instead of our else. The only kind of difference is our else does not require a conditional statement, like our if has x is equivalent to 5. The reason being is our else will only run if and all of the if or elifs, and we'll go over elifs in a bit, all the ifs and elifs above it have been returned false, or else will immediately kind of run. So it's as you'd kind of expect. If this, do this, else do that. Now for else, we can just print x is not equal to 5. So right now, when we run the program, it'll say x is 5, but then when we change our variable to store the number 6, then we'll say x is not 5. Now, another kind of introduction to our if else block, if else blocks that we can add is the elif, which is short for else if. And as you can probably guess, it'll work in the way where we check if our if statement is first true, and if that's not, then we move on to an elif. And if that's not true, then we can actually have multiple elifs constantly kind of being checked. So let's check if elif is equivalent to 6. And then we want to print out x is 6. So when we run this, it'll first check the first if statement, check if x is equivalent to 5. In that case, it isn't, so we skip that if statement and move on to the elif. Elif x is equivalent to 6, which in this case it is, it'll print out x is equal to 6. And if there were other elifs following this, it will completely ignore those. So let's add another elif real quick, and this time we'll check elif x is greater than 1. So to do greater than, you just do the greater than symbol and follow the same similar stuff, and we'll say x is greater than 1. So even though x is currently greater than the number 1, 6 is greater than 1, since it first hits x is equivalent to 6 on the elif above it, it'll run that first and then skip all of the other statements underneath it, even if they might be true. So we use elifs a lot when we want to make sure we want to just have one specific item in our conditional block to run, and once it finds it, it'll kind of skip everything underneath it. So those are conditional blocks, and you can, as you can see, we can have multiple elifs. You always want to start with an if, and you don't necessarily need an elif or else. If you just want one if to check if one thing is running or not, that's fine. But this kind of concludes how you can have if, multiple elifs, and an else, and that's all part of our conditional block. Does anyone have any questions so far? Now, while we're still on the topic of conditional statements,
I have a
there are.
sorry.
Oh, sorry, go ahead.
I have a question regarding the situation that we have. So x is equals to 6. So if x is equal to 5, then print x is 5. So the system will neglect that. But when we have is x is equals to 6, print x is 6, and else if x is greater than 1, print x is greater than 1 too. So which one would the system choose?
In this case, it'll choose whichever it sees first. So
Okay, got it.
yeah, and it'll ignore everything underneath that.
Got it. Thank you.
Yeah, no problem.
Sorry if you said that before. I didn't concentrate.
It's fine. Oh, Miles, you raised your hand. Do you have a question?
Yeah, just a really quick question.
Mhm.
So how did you guys, this is towards the beginning of the lecture, how did you guys direct the terminal into the file? Because mine's stuck on Python debug console.
So to add a terminal, you want to take a look at the top bar of your screen. There might be an option that says terminal. If you hover over that, there'll be an option for new terminal. Why don't you go ahead and try clicking that and see if that kind of pops up for you?
Yeah, the terminal pops up. I was just
Okay.
trying to get mine to look like Scott's right here.
Where's the terminal currently on your VS Code?
I typed in Python and then every time I hit F5 to run the code, it just goes to the Python debug console. That's why I was just getting confused.
Well, are you typing in Python in the terminal, or are you hitting the plus, or not plus sign, the triangle that lets you run the code?
I'm just hitting the action key F5 where it says
Um, so with action key F5, it goes into start debugging. We won't be doing any debugging in this class, so the way that you do want to run the program is either by running it through terminal, by writing Python and then the name of the file, or alternatively, there's on the top left of the, top right of the screen, there's a triangle. When you click that, that'll run the program just the same.
Okay, got it. Yeah, because every time I tried running in the day one file, it would just give me an error.
Yeah,
So-
that makes sense.
Because it's not, I guess I would say, because you know how yours says like OneDrive documents, Python, mine just says user miles, but it's not going into the file I created.
Let's see.
I
Yeah,
don't know if that makes any sense. I don't know if I sound like a dummy out here.
no, it's all right. Yeah, I haven't really messed around too much with the debugging console, so I'm also not too familiar with that. But the two ways that I usually go for running the program is the method that that Scott's currently using, or if I'm feeling especially lazy, I just press the triangle button, and that typically handles everything for me.
All right, got it. Thank you.
Yeah, no problem. Right. Um, Continuing on with the topic of conditional statements, there's a few kind of inclusions that I kind of wanted to add before we move on to the next statement, which is we only really covered how to check if two things are equivalent to each other or if one thing is greater than another thing. You can also do less than as well, or less than equals, greater than equals. So why don't we go ahead and show that real quick, Scott? So we can add that to our elifs maybe. We can say elif x is less than or equal to 0 or something like that. Oh, make sure you're tabbed out of the elif. So if so we can do the same for less than by just kind of switching the symbol we use for less than. And if you wanted to do less than or equal or greater than equal, the way you do that is you put the symbol less than or equal to, less than or greater than, and follow that up with an equal sign. So in this case, when we hit run, it'll say x is less than 0. And then if we want to include 1 or 0 as part of the elif, we just put a equal sign. So greater than or equal to, or less than or equal to with an equal sign. There we go. X is less than or equal to 0. If we didn't include that less than or and equal to and just kept it less than, the code probably wouldn't would just default to the else statement. Yeah, x is not equal to 5 because it's not including 0. And another tool for conditional statements is if you want to check if two things are true. So if you want to check if x is equal to 6, or if you want to check if, let's say, what's the thing we can check with numbers?
We could do like a range. We can do if x is less than 18 and x is bigger than 20 or sorry 12 or
Yeah.
something like that.
Why don't we go ahead and do that? So I'll have we'll just do a single if statement for showing this example. We'll say x is equal to 15 if x is greater than 12, was it? Yeah, greater than 12, and we use in this case we use the keyword and instead of, for those of you who've done C++, double ampersands. So we want to ignore double ampersands for and for or, which would typically be double bars. We just write or. How do we add hash to all the lines like that? Oh, so if you want to comment out large text, large chunks of code, you would do that with Windows with Control slash, or with Mac it would be, what was it, Command slash, was it? Sorry, I'm not super familiar with Macs.
Yep, you're correct.
Yeah, all right. So you can just you just kind of highlight the text that you want to comment out and then do Control slash. Right. Let's go ahead and try running this out. So x is 18. So in this case, we have an and statement. So we're checking if both statements are true. We have x is greater than 12, which it is in this case, and x is less than 20. So that will have our print statement run. All right. Quick questions about conditional loops conditional statements before we move on to our last topic for today, which is loops. All right, well, if there's no questions, let's move on to loops. Hopefully we'll be able to cover all of this on time before our class ends, because we do have kind of a little mini project for you guys to kind of work on your own. So let's quickly move on to loops. So there are two loops that we primarily use in Python, which are while loops and for loops. We use while loops typically when we don't know how many times we want to repeat a specific instruction. So that's when you kind of have a Boolean expression to determine how long something should repeat. So to create a while loop, let's say we want to write the keyword while, and let's say while x is less than 50. So as long as x is less than 50, we'll run this loop. In this case, yeah, let's keep that 0. And we want to print out x that number of times. So in this case, we want to maybe we would want to change what x is equal to. Otherwise, since if we leave x as 0, our while loop will check if 0 is less than 50. And since that's true always, it'll run our loop an infinite number of times. So let's kind of see that effectively right now. So it'll just continue printing out zeros over and over again in essentially an infinite loop. And if you ever get caught in an infinite loop, you're going to do Control C or Command C and inside of your terminal to break that loop. Or if you're kind of panicking, you can just X out of VS Code and log back in. But in this case, we want to increase our variable x by 1. So eventually it'll reach that 50 mark. So 50 won't be able to be less than 50. They would be equivalent to each other. And that whenever a while loop detects a false statement for its conditional statement, it'll break that loop. We've got a question. Can you do plus plus x like C++? Unfortunately, no. So if you you can't do a plus plus x, but you can do x plus equals 1. And for those of you who are new to programming, what we are basically doing with the x is equal to x plus 1 is right now x is storing a number, which is 0. And on line 51, we will increase that value by 1 and store that back into x. We do 0 plus 1, which is 1, and store that back into x. So effectively, it'll be x is equal to 1. And you can kind of do lots of different math equations like this in Python. For incrementing, changing values of variables. And that's another really powerful tool that you can do with variables. So now in this case, since we're incrementing or increasing our value x by 1 every time this loop runs and also printing it out, eventually it'll break our loop because a while loop will always break whenever that conditional statement, that Boolean expression is false. Now the second kind of loop that we want to go over are for loops. Now, for loops are index-based, or rather, they use lists to kind of determine how many times it needs to run a specific code. So you use for loops whenever you want to, whenever you know exactly how many times you want to run a piece of code. So like, for example, if we want to print out the word or string hello world 5 times, we can use a for loop that runs exactly 5 times. Now, how do we build a for loop? Well, first we're going to start off with the keyword for. Let's go ahead and add that in. And then we follow that up with a variable known as our incrementer or our tracker that'll keep track of how many times our program has run. So we'll say for I, or we can say for, so typically we use variables I, j, and k for incrementing, but you can actually use any variable name. So as Scott was about to type, he did count. That will work just the same. But in this case, we'll use for I. And then we followed up with the keyword in range. So the in range will tell us exactly how many times we want our for loop to run. In this case, the range function will be provided with how many times we want it to run. In this case, if we want to have it run 5 times, we'll say in range 5. And just like with while loops and for loops, we want to put a colon at the end, and then this is similar to how our if statements work, where when we hit enter, it'll tab us in. So everything that's tabbed in will be part of our for loop or while loop. Now, when we hit run, we should print out hello world 5 times. All right. And you can mess around with the range function a bunch of different ways. So let's first go ahead and see what happens if we print out I instead of just print out hello world. So let's go ahead and change that to say print I. And now when we run this program, we'll get whatever I is storing. So I will start at index or at value 0 and go all the way to 5, not including 5. So this is exclusively, range works exclusively. So it automatically increments 1. Yeah, this is correct. So our range function will automatically have our increments set to 1. Now, there are other ways we can kind of affect our range function. So let's say we want to have our range go from 3 to 5 instead. So we'll say for I in range, and then we start with 3, comma, 5. So 3 is our starting value, and then 5 is our ending value exclusive. So this will print out just 3 and 4. And the last thing that we can do with range functions is if we don't want it to step by 1 every time, instead maybe we want to step it by 2. And let's say we're going to print out all of the even numbers from 0 to 20. The way we would do that, or actually, let's say all the even numbers from 10 to 20, just so we can include that. Yeah. So we'll say 10, comma 20. So our range is from the number 10 to the number 20 exclusive. And then we have another comma that we use for determining how many times we're going to step. So now we're stepping by 2 every time. So when we go ahead and run this, it'll print out all of the even numbers from 10 to 20, not including 20. So 10, 12, 14, 16, and 18. So that's how we effectively use our for loops whenever we want to specifically run something for a certain amount of time. So that is while loops and for loops. Does anyone have any questions for those?
I have a question regarding the for I in range of 5. I wrote the same code that you have, but it keeps on giving me there's an error there.
Oh, at the end of your for loop, did you put a colon at the end of it?
Yes,
Okay, and then
but
when you
the thing is, next to the F at 4, there's like a red line, small red line under.
sorry, could you repeat that one more time?
Like there's a red line under the F in 4
Under
on my side, not on your screen.
right.
Like
I at the moment I can't think of a reason why that would show up. Scott, do you maybe have a idea with what might be going on?
No, the only thing I would think of is maybe an indentation error. Otherwise, we might be able to stay a little bit after class or during our office hours. We can take a look at that and work through that.
sure, thank you.
Yeah,
Yep.
no problem.
Thanks for asking the question.
All right. Are there any other questions with our loops? While loops and for loops are pretty important with some of the stuff that you'll be kind of doing for our mini project. How do you include the second number? So the second number, yeah, you just want to kind of step it by 1 if you want to include it. So you kind of go 1 over the value that you expect to end at. Now, a quick thing that we want to kind of go over before we kind of let you guys loose is how can we create a while loop that'll run an infinite number of times until it gets a specific input from our user. So first of all, if we want to create a while loop that runs forever, we just do while true. A while true loop will basically run infinitely because true will always be true. Now, if you want to get a user input, and we would use the input function. So we'll say user input equals input, and we'll ask our user to enter their name. And this is kind of simulating a password kind of a situation. So if the name isn't correct to what our while loop is expecting, it'll continue asking enter your name. So let's go ahead and say if username, or sorry, user input is equivalent to Scott. If that's the case, then we want to stop our while loop. How do we stop an infinite loop? Well, we actually have keywords that help us with flow control. The one that you'll be using a lot is the keyword break. Whenever in Python the keyword break is reached, you will end whatever loop that it's inside of. So in this case, if our user input is Scott, it will break our while true loop and kind of move on and end the program. So we can have a little print statement, or yeah, we can have an else statement that says that it's an incorrect user. And before we break, we can also say welcome Scott. Now, any line of code that we put after break will not execute if it's part of that while loop. So in this case, if we write enter your name Sahas, that's the incorrect user. If we enter the name Steven, incorrect user. If we put in Ellie, that's the incorrect user. But when we put, well, if we put Scooter, also incorrect user. But when we put Scott, then Scott will be welcomed and the program will end, and effectively breaking our infinite loop. So that's going to be a really powerful tool that you'll be using a lot whenever you're doing loops in general. Any question on that flow control? All right, now there's one very quick thing that I want to kind of plug in before we move on to announcements at the end of our lesson for today, which are libraries. Libraries are very important for Python. Um, a lot of the reason why people use Python is for all the powerful libraries that it has available. In this case, we're going to look at a built-in library called the random library, which in order to import a library, let's go to assignment. Whenever you want to import a library, you first start off with the keyword import, followed by the library that you want to include. In this case, we're going to be using the library called random. So you just write import space random. And if you want to kind of change how we refer to it, we can say as rand. So now instead of typing random all the time, we can just use rand. Now, one of the key functions that we want to use from rand is called randint. So if we want to generate a random number between a certain range, we would use the randint function. So let's create a variable and assign that to. Now, if we want to use the randint function, we can't just write x equals randint. We need to include which library it's coming from. So in this case, we're getting randint from the library rand, so we'll do rand.randint. And since randint is a function, we have parentheses at the end of it. And now our randint function will take in two variables, or sorry, two inputs. That'll include the range for what numbers we're generating randomly. And in this case, unlike our for loop with the range function, this will include both of the endpoints. So if you want to generate a random number between 5 or 1 and 10, it'll include the number 1 and the number 10. So let's go ahead and just print out x real quick. Print x.
Sorry about that. Class is getting close to an end, so my brain's turning off.
Mine as well, Scott. And then we go ahead and run. I think you're in the wrong
Yep.
file.
Same thing as before.
So this time we get the number 8, and then if you keep running it, you'll see 10 showed up. So it's including 10, and that's how we can generate random numbers as well. And then if we want to generate 100 random numbers, we'll have our print statement and our random int function in the same area. And we'll run that assignment function. And we'll get 100 randomly generated numbers. Cool. So that is everything that I wanted to cover for today's day, and right on time, actually. Are there any questions about anything that we covered today? If you have any questions, go ahead and place that into the chat, or you can also unmute yourself and mention anything that you want to say. Well, while we're waiting for any kind of questions, let's sort of get wrapped up. So today was the end of our phase 1. Actually, I'll keep recording on for just a bit longer, but there are a few announcements we want to kind of go over for our course. If you take a look at our Discord, you will notice that under announcements, I think it was like 2 days ago, we announced that we have homework or assignments out on our Discord. So if you guys want to see some of the things, or kind of how words are kind of hard right now. What I'm trying to say is at the end of our lessons, if you want to kind of practice any of the stuff that you kind of saw in today's class, we have lots of different assignments that will kind of help you guide you towards kind of learning kind of, a lot of the things that we learned, and kind of give you a structured assignment that you can kind of do on your own. Whenever you do those assignments, we will eventually have a Google form for you to submit that in, and we'll take a look at them and give you any kind of feedback that you need. And if you want to attend our guest speaker at the end of a Zoom meeting with our guest speaker at the end of phase 1, you'll have to I believe, complete 3 out of 5 of the assignments, something like that. We're still kind of, we'll keep you updated on that, but you'll have to complete a certain number of assignments in order to be invited to that Zoom meeting. But yeah, so, and then another thing, our TAs, Stephen and Ellie, have worked really hard on making a kind of Python guide cheat sheet kind of a deal for each lesson. They'll help you, those kind of cheat sheets will really help you with homework assignments and generally kind of keeping you up to date with any of this material that we learned. So you don't have to watch an hour-long lecture. You can quickly just look at those cheat sheets and get any kind of information you need from them. And those will also be posted under materials in our Python course. But yeah, that's gonna be, I think, the end of our class for today. I will stay back a bit longer for any questions or if you guys want to talk about anything. And yeah, what extensions gives the code?
And so Sahas, I have to go for a class. So
Mhm.
if you don't mind taking over for a second or for the rest of the Zoom call, I'd really appreciate it.
Yeah, no, of course. All right. Thank you very much, Scott.
All right. Thanks everyone. Thanks for coming, everyone. Remember, there's no class on Tuesdays anymore. It's all Thursdays from here on out
Mhm.
for the rest of the phase.
Yeah. All right.
Alrighty. Everyone have a good night.
All right, good night, everyone.
Where can we find the assignments?
Um,